Hi, welcome back. Today, we are going to look into the origins and the beginnings of algebra. All right. There's two main ideas we need to discuss today to fully engage with our algebra. So, for the parents in the room, let's think about our order of operations. So, order of operations, the order in which we always do our mathematics looks like this. You might remember this, PEMDAS. Oh, I'll choose a different color. But in these days, we have different names for it. So you might be seeing it as something a little bit different, like GEMDAS or something like that. So I'm going to use that instead. All right. So these are the order of operations from groups, parentheses, any sort of grouping, that always comes first. Exponents, multiplication, division, addition, and subtraction. So you might be wondering, why am I talking about the order of operations in algebra? Well, when we solve a problem in algebra, what we're doing is we're unraveling the mystery, so we have to work backwards. So what we actually do, instead of following the order of operations forward, we have to follow it backwards. And so we get something called sandbag. So we start with subtraction, addition, then go to division, multiplication, exponents, and then finally our groups. So we have to go in the opposite way when we're doing algebra, when we're solving for x. The analogy I like to use is when you leave the house in the morning, you put on your socks first and then your shoes. That's the normal order of operation. Socks and then shoes. But when you get home and you want to get comfy again, you don't take your socks off first and then your shoes. You can't do that. You have to take your shoes off and then your socks. So, socks, shoes, shoes, socks. Okay, so it's that back and forth. Okay, great. So we know we have to use our order of operation backwards. Great. That's the first thing we need to discuss. And this will make a little bit more sense in a second. The second thing is opposite operations. So we're always going to be using our opposite operations. I'm going to write down the main four operations we're going to be using in middle school. So that's addition, subtraction, multiplication, and division. We always want to use their opposites. So what is the opposite of plus? The opposite of plus is minus. The opposite of minus is plus. Opposite of multiplication is division. And of course, the opposite of division is multiplication. So I'm going to write out a problem and we're going to solve it using reverse operations and opposite. Okay, here we go. Ready? 2x plus 3 equals 11. So here's an example of an algebra problem where we're going to be solving for our x. Big key step here is we're going to draw a line to keep everything organized. I draw the line through my equal sign. Every time I rewrite my equation, the equal sign is going to stay on this line. But whatever this side equals, the other side has to equal it too. So whatever I do on one side of this line, I have to do to the other. All right. So the two operations I have here are multiplication, 2 times x, and addition, plus 3. I know I'm going to use their opposites, so I'm going to be using subtraction, and I'm going to be using division. But what order should I do that? Should I undo my multiplication first? No. I'm going to write sad meg up here, just as a quick reminder. So addition is before multiplication. So I have to undo my addition first. To undo the addition, I use the opposite operation. This says plus 3. I'm going to take away 3. But whatever I do on one side, remember, I must do to the other side as well. So I'm going to subtract 3 from both sides. What's left after I take away 3? Well, I can use the little arrow to show this 2x is still there. Nothing's changed. And that's equal to 11 minus 3, which is 8. So we did our first step. We subtracted 3 from both sides. And we have to rewrite our equation here. For our final step, we see that the operation in the equation is multiplication 2 times x. I have to do the opposite. I'm going to undo it, so I'm going to divide. I'm going to divide by 2, because it's 2 times, so what's the opposite? Divided by 2. So I'm going to divide by 2 on both sides. If I have 2 x's and I want to know how many groups there are, how many groups? It's just 1, right? So there's 2 groups of 1. 2x divided by 2 is 1x. You could write a 1 there. 2 divided by 2 is 1. Okay, but you don't need to write that 1x. It's implied whenever I write x that there is one of them. And then I keep my equal sign on this line as always. 8 divided by 2 is 4. There we go. I'm going to put a box around my solution to make it more obvious that this is the end of my problem. So, quick recap. I started with my equation. I determined what operations were being used. I have multiplication and I have addition. Then I had to determine which one to undo first. I looked at my acronym, SADMEG, and I saw that addition came before multiplication. So I had to use my addition first. Then I looked and I saw what were the opposites. The opposite of addition is subtraction, so I had to subtract. The opposite of multiplication is division, so I had to divide. And there you go. You get your final solution. Often, you'll be asked to check your work, and I want to show you really quickly how to do that. So what we do is we take that original equation and we write it again. 2x plus 3 equals 11. But instead of using x, what could I use instead for x? Well, I know that x equals 4. So instead of x, I can replace it with the number 4. This way, we can check it to see if it actually is 4. Does it make a true equation? So I'm going to write it again. 2, and then in parentheses, 4 plus 3 is equal to 11. Well, let's find out. What is 2 times 4? That's 8. 8 plus 3 is 11, and that's equal to 11. This is a true statement. 11, in fact, does equal 11, so we're good. I've got a little check mark there. Everything is perfect. So there you go. This is the long-winded way to solve these problems. Reverse the order of operations. Use opposite operations. Check your work by plugging in the solution back into the original equation. If you get a true statement, you were correct. All right. We're going to be practicing this a lot, so stay smart, stay safe. See you next time.